So a puzzle, selling energy and saving energy. And I will explain the puzzle. So it's joint work with colleagues in Paris, Glachant, Giraudet from CIRED, and Jean-Philippe Nicolai from University Paris-Nanterre. This is really a work in progress. This is the second time I present the paper, so I mean, I decided to take risks in presenting new stuff today, and so I hope that you will find it interesting. So, the puzzle. In fact, there is, in this very important EU Energy Efficiency Directive adopted in 2012, a very important article, Article 7, which says that each member state should introduce a so-called energy efficiency obligation schemes, so EEOS. And in this EEOS, this article says that energy companies must save an annual 1.5% of their energy sales. And it is also said that some countries can adopt other approaches to reach the same goal. In practice, 15 member states have adopted such energy savings obligation schemes. France, my country, Italy, this country, Spain, Poland, UK, if I take the big countries, and so how does it work? So this is the reason of the title. So the principle is this one. First, you have a legal obligation on energy companies, which are called obligated parties, to achieve a quantitative target of energy sales reduction by a certain date. When I say energy companies, in practice, they are, the obligated parties are energy retailers, so operating on competitive markets, gas, heating oil, electricity, of course. Then how will they do so? They, in practice, what they do, each of these companies, they basically subsidize energy efficiency investments. Sometimes they target their own customers, but sometimes they target other customers. It depends on the design of the program. Of course, these investments should be additional. They should not have taken place without this, what they call inducement by the energy companies, which is this money which is given to the energy users investing in energy efficiency. Then for each investment, there is a calculation which is done using standardized methods which estimate the quantity of energy which has been saved by this individual investment. And these calculations generate so-called certificates, white certificates, or energy saving certificates that are used by the obligated parties to justify that they comply with their obligation. Okay. This is the system. So other names, white certificates, demand side management, utility efficiency, energy efficiency program, energy efficiency resource standards. Okay. This instrument is not very well known. Who is aware about these instruments? Okay, 5 people. Who is aware of the existence of this carbon market? No, I'm joking. So, in addition to these basic principles, there are different flexibility mechanisms that are possible, and it depends on the country. First, in certain cases, the obligated firms, they can induce investments anywhere in the economy, so not only on their customer basis. They can even, instead of inducing investments, they can purchase certificates from others, so there is trading too, trading of white certificates. And you also have the possibility to, for non-obligated parties to generate themselves certificates. They are not obligated parties, okay? And they sell the certificates to the obligated parties, okay? So you see that it can be quite complex. And one way to show that it can be a mess is to describe maybe the most sophisticated scheme in Europe, which is the French system. So the French system, the first thing is that you have, so here, an example where you have two obligated suppliers with their customer bases. And so they induce, the green arrow, they induce investment. And in return, they get back these certificates. So this is not the full system. They can also target the customers of their competitors, okay? This is called external compliance. They can exchange white certificates, trading, and you also have so-called délégataires, which are other companies, for instance, ESCOs, that can induce investments, get the certificates, and resell these certificates to the two obligated parties. And so you see the number of arrows is incredible. So it has been said this morning by John that it's difficult. We need to explain how the carbon market works, you know. You see that for this system, it's even more challenging. Imagine to explain this to her. Okay, and so it also exists in the US. It is called over there an energy efficiency resource standard. But in the US, it's totally different because this concerns mostly electric utilities that are vertically integrated. So the obligated parties are regulated monopolies, and these obligations are part of the regulatory relationship. So it's not, it's very different from what exists in Europe. The International Energy Agency likes a lot this approach, and for instance, there is this graph in their last report on energy efficiency, which shows the coverage. So the vertical axis is the share of global total final consumption covered by these obligations, and you see that we are now at something like 18% of the demand, of the world demand. So it's so you don't know the instruments except 5 people here in the room, but it's not at all a detail, okay? It's an extremely important instrument. In France, it's 4 billion euros per year of subsidies distributed by these obligated parties. To compare, it is more than the receipt of our carbon taxes, which is 44 euros per ton. It is more than the amount of public subsidies also distributed by the government. So it is huge. It's something which is huge, okay? So this lecture is extremely important. Okay. So what is this? So why ask retailers to reduce their sales, basically? Okay, so it's very paradoxical. You should keep in mind that it is an alternative option to something which would be much more straightforward, which is to combine energy taxation and investment subsidies, energy efficient investment subsidies. Because what is done by these companies? I mean, they subsidize. So it's private subsidies, not public subsidies, but they subsidize, and they recover the cost of these subsidies by increasing their price. So they do something like equivalent to increase an energy tax, okay, or they raise an energy tax, okay. So why, instead of letting the government doing this, combining a tax plus subsidy, why delegating this role to these energy companies? And so here the argument is an informational argument. This is the idea that these guys, they know better their customers and the energy behavior, consumption behavior of their customers And so they would be able to be more effective in finding what are the cheapest investments, energy efficiency investments. They are able to adjust the level of the subsidies in order to reduce windfall profits and what is called in this energy efficiency literature free riding. I don't like the term, but this is the term that it is used. Okay, so this is the main rationale for doing this. But when you talk to the governments, to civil servants, I've done this recently in the French administration, they love this instrument, okay? Because basically what they do is also to outsource the implementation of a policy. So it reduces administrative costs from their perspective. You know, this is something like an energy tax, but which is not an energy tax, which is not visible. So in terms of political risk, you know, it is very beneficial. Nobody knows, in fact, okay? Except what is visible is only the subsidies, okay? Nobody knows, including you, so you see that that's maybe an advantage of it. Until now, I didn't find any theoretical paper analyzing this instrument in the literature, in the economic literature, except 5 papers published on not on this type of scheme, but the US equivalent, so obligations for vertically integrated natural monopolies, and obviously the microeconomic properties are totally different. There is no paper on this scheme as it is in Europe, so in liberalized energy markets. I don't know also any empirical paper on this scheme. When I say empirical, I mean with an econometric approach, okay? Because there are case studies and qualitative analysis of this. But, yeah. So, yeah, so we should, this is also a message I want to put forward. So we should also deal with instruments that have been invented by these practitioners that are very particular. We have things to say about that, so we should work on that more, okay? Okay, so this is the first paper. Also, as a first paper, it would be an exploratory paper, not very ambitious, etc., just a first trial. So what do we do? So what we do is to propose a model, an industrial organization model, which describes this type of scheme, assuming the imperfectly competitive energy supply markets, like they are in Europe. And we put the emphasis on this idea that these energy suppliers, they are informed about their customers, on their customers. And with this model, we compare the incentive properties, the welfare properties, and also the distributional properties of different type of energy efficiency obligation designs, adopting a cost efficiency perspective, so keeping the level of the obligation exogenous. And especially, we concentrate on 2 design components, the presence of trading or not, and whether it is allowed to do external compliance or not, and I will be more precise in a minute. So the model is very, very simple. It's what I like the word, a colleague of mine used this word, it is a toy model, okay? Something, and so the advantage of toy model is that you can use graphs, and I will essentially present all the results with graphs. And there are just a couple of equations which are on this first slide, and then we'll skip to graphs. Okay. We will switch to graph. Let's switch. Okay, so we adopt a framework which has been, which is very well known in this IO literature on network industries, because it is a framework developed by Lafont, Tirole, and Patrick Ray in 1998. So it is a no-telling framework. So we have a continuum of energy users which are on a segment, 0, 1. we simplify drastically their thing by assuming that they either consume 1 unit of energy or 0 units. At each extreme, it is of the segments, you have 2 energy suppliers, 1 and 2. And each energy user, so located in one point X of the segment, has this utility, UI, which is difference between V. V is the intrinsic surplus derived from consuming the energy service, like heating, lighting, etc., minus T times the distance, X minus Xi, is the distance between the customer and the supplier, okay? A transportation cost. The idea here in this type of framework, and the idea of Lafond, Thiol, is this capture different connection costs or loyalty, trade loyalty, etc. Okay? And each energy user can invest at a cost I to reduce its consumption. And we assume, for simplicity, that, in fact, it leads to 0 consumption. Okay. So, graphs. So you have the segment. So you have one supplier at 0, another at 1. U1 here is the function describing the utility of each of the energy user, which is decreasing when they are supplied by the first utility. And you have the symmetric utility if they are supplied by the other supplier. And you remember from your textbook that in this type of environment, price competition will lead to this equilibrium where they choose the same price, which is equal to the transportation cost. And so this is the business as usual scenario. They take, as they are symmetric firms, they have half of the market each. And we assume that the investment I is higher than this price, meaning that in the status quo, there is no energy efficiency investment. Okay, so let's introduce an energy efficiency obligation in this model. So the energy efficiency obligations consist in the obligations to subsidize the investments by alpha energy users. And so we have this timing. First, each firm chooses which customer will be subsidized. Then each selected customer receives the subsidy and invests. Then the firms compete on the energy market. They set their price. And there is this fourth stage where customers can decide to invest. Customers who have not invested can decide to invest. And what is important at this stage is that the informational assumptions is that, if I come back to this graph, each utility knows where its customer is on the segment, but does not know where the customers of the other supplier are on the segment, okay? Okay, so let's, I've worked hard in putting some animation in the slides, so yeah. So let's start with the simplest design, where the supplier can only induce investments by on their customer base, okay? So what they will do is to offer a subsidy which is equal to the difference between the investment cost and the energy price, P0 here. As these two variables are uniform, their choice is only about what is the impact of this choice on the energy price, okay? And so it is easy to show that what they will do is to target these guys that are in the middle. So here, alpha, yeah. So if here you have this alpha in red, which is the alpha customers that will be subsidized by the firm 1, and in green, the alpha customers that will be subsidized by firm 2. If they do that, if they target these guys, it means that these guys, they will no longer consume energy, and so they will be able to increase the price on the energy market up to P alpha on this graph, okay? So this is the best option for them, because by choosing these guys in the middle of the segments, they are able to increase the energy price of the markets, okay? So this is what they will do if we use this design. And so what is very important here is that they target their own customers by design. We have decided to. Now let's assume, as it is the case in many countries, that they can also, a new design, they can also target the customers of the other supplier. It is easy to show that, in fact, the first equilibrium that I was describing, which is to target the less loyal customers, but your less loyal customers in the middle of the segments, it is not a national equilibrium. Because you have an incentive to target the other guys on the opposite side of the market, it will not affect the level of the subsidy, because here there is the uniformity assumptions on the level of the investment. And you will avoid, if you do that, you will be able to sell energy to your customers. Whereas if you, of course, subsidize your customers, you diminish your sales, okay? So if you allow for external compliance, it is quite straightforward that the equilibrium is an equilibrium where everybody is targeting the other competitors' customers, okay? What is very important is that doing so, the equilibrium price on the energy market is lower, because you are no longer able to remove these marginal customers in the middle of the segment, okay? And so it means that by doing so, by targeting the other guys, the firm makes less profit than under the first scenario. And so, at this stage of the analysis, we can so derive the major findings on the mechanisms that are behind these programs. The first finding is that we have seen that allowing external compliance leads to full external compliance. So it means that the firm, they do not target their customers, so they do not exploit their informational advantage. I remind you that a key rationale for these schemes was to constrain, to focus the firms on their customers, on what they know, okay? We have also a scheme, if you allow for this external compliance, where there is no energy price increase, so you lose the energy tax effect. And this is bad for the companies because their profit is lower than under the scenario with only internal compliance. Okay, so at this stage of the analysis, so this is welfare neutral because I have assumed that the investment cost is uniform, okay? But what if it is not uniform? So how many time I have? 10 minutes? Oh, it's okay. That was some minutes ago. Okay, okay. Okay, but I will be very quick now. Okay. So what we have done in the paper, and so this is the best version of the paper, is this one beginning now. So what I've done before is just to simplify to give the intuition. Okay. So what we have done is to assume that the suppliers, they are not only better informed about the utility of their customers, they are also better informed about the investment opportunities of their customer, okay? So they have two informational advantages, something that you can say to be quite realistic, okay? To simplify, we have said that, in fact, the assumptions is as follows. You have two types of customers with different investment costs, I-min, I-max. We assume that both types, they are uniformly distributed over the segments. And we assume that each firm privately knows the investment costs of each of its customers, okay? And if you do that, under this assumption, so we can investigate now cost efficiency aspects, because under these assumptions, it is immediate that cost minimizations requires to target only the low-cost customers, so the customers with type I-min, okay? You can see if so under this assumption, it is only feasible if each of the suppliers targets its own customers, because they are not able to identify the type, the cost of the investment cost of the customers supplied by their competitor, okay? So it means that to achieve cost efficiency, under these assumptions, we should have internal compliance, okay? And we will not have internal compliance in all cases because of the, exactly because of the mechanism that I have just identified in the simpler version before. Each firm will have an incentive in order to increase its sales, to target the customer of their competitors. Doing so it is a benefit for them, which is to increase their sales, or to avoid decreasing their sales. But of course, there is a cost, which is that as they do not know the investment characteristics of the customers, they will target also a mix of low-cost and high-cost customers, okay? And so there is a trade-off. And we show, and I skip everything, and we show that in some cases, they will target their customers and so achieve cost efficiency. And in other cases, they will not, okay? And so this is what is written on this table. On this table, for different level of S, I describe whether cost efficiency is attained or not. And S is this expression below the table, which measure the cost of subsidizing your competitors' customers. When you subsidize your competitors' customers, you lose money compared to your competitors because you are not able to target only the low-cost ones. And this S measures the size of this loss. And if you have, what is important is that if you have, of course, IS, they will always target only their customers, and it will be cost efficient. But if we have this intermediate level of S, we end up with contrasted results between the two designs. When there is when external compliance is not authorized, it will be cost efficient because you force them to target their customers. But if you allow for this external compliance, it is inefficient. And so here the lesson is that allowing external compliance is bad in the context of this model, but because here firms are symmetric. Huh? And so what we do, and this is I finish now, what we do then in this article is to introduce some asymmetries between firms, and of course it will attenuate these results. If firms are asymmetric, for instance here, we assume that all the customers supplied by firm 2 have a cost, an investment cost, which is I min. In this case, it is clear that it creates an incentive to target the customers of firm 2. And doing so, in this context, it means that if you allowed for external compliance, there would be a benefit because firm 1 would be able to target the customers of the other firms. Okay. And so basically it attenuates this cost inefficiency, but this cost efficiency survives, and I will not establish the results in this presentation. And one way to finally cancel this inefficiency of this system is to introduce trading. So trading is seldom, in fact, only 3 countries in Europe. France, Poland, Italy, yeah. It is straightforward that if you introduce trading, assuming perfect competition on the certificate market, you will restore efficiency. I mean, it's simply the cost theorem which is behind, okay? So trading is good. The problem is that these markets are not competitive. You cannot assume that the energy markets are not competitive and that the certificate market is competitive there. Okay, so what are the takeaways of this exploratory analysis? We have this maybe counterintuitive result that providing flexibility is not necessarily good for the cost efficiency of these schemes because of this prisoner's dilemma where firms target their competitors' customers. Clearly, it means that imperfect competition disturbs the cost efficient, the functioning of the system compared to the initialized. Disturb. Trading can solve the problem, but only if the market is competitive. If it is not, it will not solve fully the problem. And so what we are doing now is to develop an extension to include this aspect into the analysis. And finally, one question remains, which is not addressed in this paper, which is that, so is this complicated instruments with potentially important inefficiencies is better, more efficient than the alternative options, which would consist in simply combining an energy tax plus public investment subsidies. If you do a simple economic model, of course, the immediate answer of the economists would be, no, of course, it is better to have only an energy tax that will do the job, okay? So it means that if we want to address the last question, it's complicated in terms of modeling choice because you need to introduce some assumptions on the inefficiencies of the governmental interventions, so governmental failures. And so, again, something that we have in mind for the future. Okay, so thank you.
To you.